Good morning, everyone, or good afternoon, depending on where you're attending this webinar from. Firstly, I would like to thank you all for taking time out from your schedules to attend this webinar. Welcome again. Today's webinar topic is cloud-based head-end system or meter data acquisition platform for DLMS COSEM metering. To introduce myself, I'm Gautam, and I take care of Europe and South America market for Kalkitech ASC offerings. ASC being the US-based company acquired by Kalkitech in 2014-2015. Kalkitech has long been an advocate of open standards and standards-based communication to facilitate interoperability in the true sense. We have been active members of the DLMS User Association since long, and now DLMS is de facto the standard metering protocol used extensively across the globe, excepting North America, where ANSI C12 is still prevalent. We were the first to come out with DLMS libraries, both server and client. Server for meters and client for meter reading applications like head-end system, DCUs, etc. Our library is used extensively by more than 50 leading meter manufacturers around the world, and hence it is so much more simpler for us to interoperate with these meters using our head-end system. In addition to the standard DLMS, we have extensive experience in various companion specifications, namely the Japanese TEPCO, Spanish Iberdrola, Dutch DSMR, Italian gas metering CIG, the Indian IS 15959, TNB Malaysia, SEC Saudi, UK, Spotus Russia, among others. Our DLMS offerings, namely the library and tools, readily comply to a few of these standards, and we can comply to the rest based on specific interest. A few points to keep in mind before we start off. Since we have a large number of participants, this is a listen-only webinar. However, to facilitate clearing of your doubts or queries that may arise during the course of the webinar, you can kindly send us your questions by typing in the window during the talk itself. We would try to address most of your queries here or come back to you individually in case we run out of time. The presenter talk would be for 40 to 45 minutes, followed by a set of questions selected at random. I would now like to introduce you to our panelist for today's webinar, my colleague, Mr. Nirmal, AVP Product Management. Nirmal has over 15 years of diverse experience in substation automation, communication protocols, and power utility automation, which includes smart grid solutions for distribution networks, DER integration, smart metering, and IoT solutions. Nirmal is now responsible for product management and marketing for our energy IoT offerings. Without any further ado, I would like to pass controls to Nirmal, who would take it forward from here. Over to you, Nirmal.
Thank you, Guru. Hi, good day to all. So let's directly jump on to the today's session. So today we will cover a cloud-based DLMS COSEM metering head-end software solution. What are the benefits of this cloud-based solution and how it is used in various deployment scenarios. So agenda would be we'll give a brief idea on what is SaaS based software, what are the benefits compared to a traditional software model, and then we'll move on to Kalki.io metering pack, which is a SaaS offering from Kalkitech, and what are the benefits of the Kalki.io metering pack for various user segments. and how this software can be architect to your particular solution requirement, and what are the key features of the software and application use cases will also be covered in today's session. So let's look at the difference on traditional software and SaaS. So SaaS is software as a service, which is a licensing and delivery model for the software, and it's been offered as a subscription basis. In this SaaS model, software will be hosted on a central server, and user can access the software using a browser, web browsers. So typically, the difference from a SaaS-based software and traditional softwares would be how the software will be charged to users, and the scalability of the software, how what are the resources it can consume over its lifetime, availability of the trial versions, installation and the ready-to-use features, availability of the updates, and availability of the complementary apps. So if we go into in depth and compare with the traditional software models, SaaS will be normally available on a subscription fee. That means you need to pay only for the resources or the devices which you want to communicate to in case of the metering SaaS. But in case of traditional software, it has got the one-time fee. You need to spend the capex to purchase the software and install the software in your network. In the SaaS-based software, it has got unlimited usage, and the scalability is said to be the infinite. Means you can scale as far as you have got the backend resources infrastructure in place. But in case of traditional softwares, the scalability and the resource usage will be limited only up to the hardware which you will be having in the central system. The SaaS software trial version is always available, and it will be trial in the sense for testing, and for the staging environment there will be separate instance of SaaS software usually. While in the case of traditional softwares, trial will be limited or may not be available at all. And in the case of SaaS, there is no installation required at any central location or any particular infrastructure. It's already installed and is ready to use, and you don't need to spend more time on installation and the configuration of the system. But in the case of traditional software, a lot of time is spent on the installation of software and the setting up the system ready for the particular deployment. And all updates are automatic and often free in case of SaaS to mainly comply with the regulatory and the security compliances. While in case of traditional softwares, so updates will be available only in the warranty timeline. After that, updates may not be available, or it will be charged heavily. Also, SaaS comes with the complementary apps where you can add more applications on top of the SaaS platforms, and make use of the data which has been available in the SaaS, and build more applications, more value additions on top of the software. While in case of traditional softwares, the complementary apps will be very limited or often costly. Let's look at the benefits of hosted metering headend, which we want to discuss today. So main benefits would be the flexibility of how the software. In case of metering headend, you can have the flexibility of adding n number of devices or meters into the software, and n number of storage into the devices into the software. So all the devices and storage and network bandwidth, all this can be added on demand whenever required. You can start with a minimal resources initially, maybe for maybe 10 or 15 meters initially, and gradually goes up depending upon your demand. Another benefit would be the evaluation of evaluate and testing before scaling the system. So you can, as I mentioned, you can start with a minimal number of devices. You can test it, validate the network, validate the communication, validate the data. Once you're confirmed and satisfied with the solution, you can scale it up to n number of devices or meters which you require for the deployment. Another advantage would be the acceleration of innovations. So normally the end users would be more interested in core business problems and solutions rather than spending time on the infrastructure maintenance and connectivity issue solution. So end user who is using the system can directly focus on the applications or any value added apps which needs to be built on top of these SaaS. You can build that application, test it, and roll out those applications easily. And SaaS also provides easy and extensive tools for troubleshooting and issue identification, like the infrastructure related issues as well as the connectivity related issues. So another advantage will be the cost optimizations. As we already discussed, SaaS does not have any capex. You don't need to spend more initially to purchase the hardware as well as the software. You can start with a very minimal configurations or minimal number of devices or settings. So the capex investment is very limited, which will again benefit you for the long run on budgeting and the ROI optimization. And because of the limited maintenance requirement, you don't need to spend your resources to maintain the infrastructure and the network. All the infrastructure maintenance and network maintenance will be done by the SaaS provider, software provider. So the maintenance cost or the operations cost for your net system would also be very limited. And SaaS also provides you the additional automated services for the disaster recovery, data backup, etc. So which will also help you to save more resources as well as more cost for you. In terms of security, so the SaaS always comes with the best-in-class security and compliance tool because of the regulatory requirement. And there is no in-house expertise required to manage the security aspect of the system. So that can be managed by the SaaS service provider. And data privacy concerns are addressed with standard solutions available in the SaaS software. And we can also increase the customer engagement by building more apps. Maybe it could be a mobile apps, which can be any end user can install it in the mobile and take this data from this metering headend. It could be a building software, or it could be a energy monitoring software, anything, which will engage your customer more, and which will again benefit for your business. So let's look at the Kalki.io metering data pack, which is again a DLMS COSEM headend hosted on the cloud. So Kalki.io metering pack benefits for different customer or user personas listed in this particular slide. For example, the industrial users can use Kalki.io headend to monitor the data from energy meters, to optimize the peak demand charges. can monitor the network, so energy consumption, and also it could also benefit them by improving the power factor utilization in the network in the load. And also by regularly monitoring the power quality in the industries, industrial users can reduce the equipment damage and thereby reduce the operational cost of the entire system. In case of commercial buildings, these users can use the metering data to analyze the energy footprint, thereby avoid the wastage of energy uh, over the lifetime. Commercial buildings can also integrate head-end, calculator metering head-end with their building management systems or energy management systems over the extensive REST APIs we provide at the backend. So that is also a value additions which a building commercial building management team can avail of. For the utilities, it could be distribution utilities or for the transmission utilities, metering head-end can be used to lower the overall cost of ownership of that acquisition and maintenance. Means the typical SaaS benefits, like you don't need to have a in-house expertise for the maintenance of the infrastructure and the connectivity issues. Which will be provided by the SaaS provider. And SaaS also been tested and validated with multiple makes and models of meters, or the interoperability part is also being complied with multiple makes and models of meter, which can be utilized across multiple user segments as well. For residential consumers, like for townships or residential complexes, I can use this Calcio head-end, metering head-end for the reducing the energy footprint by regularly monitoring the energy usage. And they can also use it for billing application, like a tenant billing application, or maybe prepayment applications, or even as a consumer portal for all the tenants available. So to go in depth to the software, so these are the core services which Calcio metering head-end offers. From the connection management, in a sense, Calcio metering head-end has got extensive list of protocol supports. In case of the metering side, it supports the DLMS client, which has capability to connect with the multiple makes and models of meters, as well as there are templates available to communicate with different companion standards supported in the market. And it also has capability to connect with the edge devices, where your meters are connected to edge devices over a last mile network, like a PLC or RF, LPRF, or even a DC chain RS-485 network. Edge device will collect data from these meters, and Calcio can collect data from these edge devices as well. And if you have got another interface like MQTT or OPC UA, that can also be integrated with the Calcio metering head-end. On the device management, Calcio metering head-end can be used to configure the device, manage the firmware, monitor the assets, and monitor the faults of the end devices, like meters, as well as for the other communication devices or communication modules, like NIC, a network interface card available in the meter, or it could be edge devices available in the field. So all the device management can be done directly from the Calcio head-end. And there's a data presentation layer available, which has got the dashboards, which is fully user configurable, alerts, there's notification channels where you can configure the events from the platform, as well as from the field, or that from the meters, or it could be any events from the communication network. All the events can be configured for notification on SMS, or could be on email, etc. So there are the various notification channels available on the platform. And there's an extensive reporting tool available as part of the platform. We can configure the custom reports from the meter data as well as communication history data. And for data distribution, as we discussed, you can build more application on top of the Calculator metering head, and it could be a prepayment application or maybe billing applications. So all these applications can make use of the data sources or the REST APIs provided by the system to collect as well as transfer data to and from the Calculator platform. So let's talk about the configuration management, some few concepts which we have introduced in Calculator. So it's template-based configuration, which means that in case of DLMS meters, that there's an extensive list of templates available in the platform, and depending upon the makes and model of the meter, as well as the compliance standards like the Indian compliance standard or TNB or SEC, etc. So all the compliance standard templates are available. You can use any of these templates, instantiate number of meters you want to connect to, and configure those meters, and directly you can connect with the meters then and there from the head end. Or there's an additional tool which we are providing using the MSSL export import mechanism. You can configure all the meters on an Excel file and import those Excel file into the platform so that you can configure multiple meters in a single shot. And again, all the configurations which you want to transfer to the devices like edge devices or maybe to the meters, it can be done through the Calculator.io remote configuration option. And on the firmware side, there's a firmware management module available where it can be used for monitor the versions of these firmware available in the meter, as well as communication card, or it could be an edge devices. And all the firmwares for these devices can be updated from the Calculator.io platform. And on the connectivity side, we already discussed the DLMS support for different makes and models of meter, and the multiple makes of edge devices can also be supported in the Calculator.io platform. And one more additional service which we are providing is using the device agent, the software stack which we provide, which can be deployed on an devices or edge devices. Using this device agent stack, there's an auto discovery and registration mechanism available. We don't need to configure those devices in the head end. So once these devices are deployed and powered on in the network, automatically it will get registered with the Calculator.io and automatically it will get configured in the platform. So that is again additional service which we are providing. And the security, there's an extensive role-based access control using a PKI infrastructure which we build in, so that you can even control the meters which you want to share with the particular users, and even data which of each meter which you want to share with particular users. So there's an extensive role-based access control mechanisms built in the platform to share as well as to add more users in this. And all the user configurations could be a configuration of the edge devices or meters, or it could be a configuration in the platform, are being logged in a single audit trail, so that all the logs can be monitored from a single location. And the communication from all field devices to the cloud system will be totally encrypted on TLS 1.2 tunnel. And there are different environments which Calculator operates. Like there's a production environment, there's a staging and testing. And so you could start with a staging or testing environment. You can start with a few meters, test those meters, validate the data, validate the communication, validate the application for which you want to build it. And once all the validation and verification is done, then you can upgrade. We call it promote. You can promote those application and data from the staging to the production, and you can scale from the production servers. So that is again additional services which we are providing. Again, All the communication logs, pole statics, availability reports are also being provided. These are the few tools which is been available in the platform to mainly for troubleshooting and issue identification purpose. So the connectivity options which is available, we as per the requirements from various customers segments, we have got extensive options to connect DLMS meter with Calculator.io. The primary option would be the meters connected to an internet using static IP. It could be a modem or any internet service provider network which will be connected with the meter having the static IP. And these meters can be configured in the DLMS client or server mode. That means if it is a server mode, Calcio can directly request data from these meters using the polling, device data polling. Or if it is a client, if it is meters are configured in the client mode, meter can initiate the connection to the Calculator.io and push the data to Calculator.io whenever required. It could be on schedule base or it could be on event base. So another option is having the meters having a dynamic IP SIM card, and their meters needs to connect with Calculator.io. One option we have is you can have the device agent, a small software stack which we provide that can be implemented on the modem or the meter, and this will take care of creating the tunnel, connecting with the Calculator.io and creating the tunnel. And once the tunnel is created, the DLMS communication to happen through the tunnel. So one more advantage of using device agent is auto discovery and auto registration. You don't need to configure those devices in Calculator.io. So automatically when device agent, meter with a device agent is deployed, it will connect with the network and create the tunnel, and automatically the registration and the configuration will happen then and there. Another deployment scenario is a DLMS meter which has been deployed on a private network. It could be a service provider private network, it could be a VPN network, and we need to connect, Calculator need to connect with those meters. So one option which we provide is there is a custom VPC. A custom VPC is a virtual private cloud extension of Calculator.io. You can install a sync proxy. That's a proxy service which will take care of connecting with the field devices, and the service provider can extend the private network up to the VPC using an IPsec tunnel, and Calculator can gather the data from this meter through the proxy through the private network provided by the service provider. So another option is instead of having an IPsec tunnel up to the VPC, service provider can have the sync proxy on premise in his private network, and sync proxy will take care of creating a tunnel up to the Calculator.io or the public internet, and then sync proxy will act as a bridge from the private network to the public network. So again, all the communication to the internet will be over the secured TLS 1.2 tunnel. Another option is all the meters connected to the edge devices on various last mile networks, including the low power RF, PLC, RS-45 network, and sync devices or any other third-party edge devices can collect data from these meters, and these devices can connected with Calculator.io over a public internet. So these are the few deployment options which we support, and again these are all customizable, and if there's any specific requirement, the communication network can be fine-tuned as per that particular requirement. So to talking about the DLMS capability on the platform, so as we discussed initially, it supports various companion standards out there in the market. So so all the LMS specific standard interfaces classes is being supported in the platform, like the normal profile and register rates, which is a standard use cases for of an automated meter reading applications. So that is by default supported in the meter data collection module. And the data can be collected on the HDLC, that is a serial version of the DLMS, as well as the TCP IP profile of the DLMS. And again, the IP connection can be on IPv4 as well as IPv6 connection. And the polling or data collection mechanisms, it supports various types of data collection mechanism, that is on schedule polling. Like it's an outbound connection which we create from the calculator.io and connect with the meter and gather data which is required or configured by the user. And there is an extensive poll configuration option available in the platform. You can configure it as on a periodic basis, or you can configure it on a wildcard basis, or you can configure it on a particular day, or particular month, day of the month, or particular day of the week, or time of the day, etc. So those are extensive mechanism to configure the poll schedules in the platform. And there's also an on-demand polls, or a user, any operator wants to see the data on demand from the meter, so we can issue an on-demand poll from the headend, or it could be an on-demand poll from a third-party application, and which will Calc.io will read the data from the meter and provide it to the user. And other possibility is inbound connection from the meter, that is pushing the meter pushes the data. Or it could be on schedule basis, like if it's a profile data, it could be meter can push data on every 15 minutes, or maybe every 30 minutes, or every 1 hour, or it could be an event based, like if there isn't tamper event happen, then and there the meter will establish a connection and push the data to the calculator. So those both inbound and outbound communication is possible. And another feature which is built on top of the DLMS, is not a DLMS feature, it's a gap fill poll. Will go through the database and see whether there are any gaps in the data and poll the particular data. And then on the meter programming, there's a metrology configuration option, like if you want to change the CT ratio or PT ratio of the meter, or any other metrology configurations, it can be done through the DLMS interface available in the platform. And it could be a building configuration, like there's a scheduler IC interface class defined in the DLMS standard, which is supported in the platform. You can use the scheduler IC to change this billing time. Like if you want to change the billing date from 1st of every month to 5th of every month, we can do that from the billing scheduler feature available in the platform. And there's a protocol settings, like the communication setup, TCP setup settings, or the IPv4 v5 settings can be updated, changed from the platform using the communication setup interfaces classes available in the DLMS. And then the time synchronization or time distribution of from the headend from the calculator to all the meters out there in the field. It could be on time setting can be done on 2 ways, like clock set, means you can write the time, absolute time, directly onto the meter, or it could be on shift basis, like if you can shift the time maybe in 5 seconds interval till the time of the meter is been adjusted to the standard clock. So both type of time synchronization is support. And last but not the least, that the meter programming, we need to will be have a support for the firmware update over the air. So for the meter firmware, we use image transfer IC available in the standard. So using the DLMS standard, using the image transfer IC, so the firmware of the meter can be transferred from the headend to the meters, to multiple meters in a single shot. So that is again advantage. So you don't need to choose each meter and transfer these files to each meter. You can group the meters in the calculator.io platform and initiate the firmware transfer to all the meters available in that group in a single shot. So the platform will take care of transferring these image to multiple meters at the backend. Now, the advanced metering capabilities, like for example, the TOU tariff, I want to change the tariff zones, or it could be tariff, even tariff ratings, currency values, which for each zone. You can do that using the activity calendar interface class available in the DLMS client in Calculator platform. Or it could be a demand response feature like a connect disconnect, or maybe load limiting. So these are all I have specific interface classes available in the standard, and it's also been supported in the header. Then on the security side, there's a single sign-on authentication, like LLS or HLS support is available. And data transport security, like encryption and authentication, as per the standard like security suite 012 is being supported in the web. And the key transfer, for the transfer the keys for the security, there's interface class specifically for the security setup available in the platform. So this slide gives a high-level idea on what are the add-on application or application use cases which can be built on top of the Calculator metering head end. You can so the metering head end's main responsibility to collect the data from different makes and different models of meter on various protocols. So all the data collected from the field devices can be made available on a data source or the REST APIs. And you can, or the application builder can build an applications using this REST API. And these are the few applications which possible applications which can be built on the platform, like energy optimizations, or it could be a billing application, or DER, distributed energy resource management application, or it could be net metering, like if you have got generation, solar generation at your premises, you can use it for the net metering applications, or sub-metering, prepayment. Even if the meter is a postpaid meter or a normal meter, you can have a prepayment application built on the platform, and that can be used to disconnect the meter whenever required. And other possibility like demand response, loss accounting, theft detection, peak load management, consumer profiling, neighborhood comparison, consumer portal. So there are huge possibilities of applications which can which make use of this data and gives a value addition for the end users. So these are the few subscription options available for the Calculator.io metering head end. So there's a base price, which is a monthly subscription price per meter, and base price includes minimal storage and minimal number of users and minimal network usage as well as part of the base plan. And you can add more storage or more users or more network usage as per the application requirement. For example, network usage, if you are building an application which is used for consumer profiling, so you need profile information, load profile information from the meter on every 30 minutes or maybe every 15 minutes. You need to read the data from the Calculator.io using REST API periodically. So in those applications, network usage has to be higher, even though the storage and number of users may be less. So you can fine tune these add-ons as per the final application requirement.
To request access.
Sorry, so we'll just give a brief a video on how to sign up to the platform. Here it comes.
To the platform, navigate to www.kalki.io. The portal here explains the different access packs available in the platform. Here you have a button for sign up. If you click, it will navigate to a page where you can request for sign up. Enter your company name, phone, email address. Once you accept the terms of use and privacy policy, you will be sent a verification code to the email ID that you have entered here. Once you enter the verification code, our support team will evaluate your request and send an activation link to the same email ID, using which you can set the password for your user account. Once you use the activation link and register the user, navigate to the URL assigned to you, log in using your username and password. There is a help section where you can access the user manuals for all the modules that are available in the platform to gain more knowledge on the features of the platform and how to do your configuration, etc. in the platform. For more information, please visit www.kalki.io or contact us at sales@kalkitech.com. Thank you.
So we have got a few video snippets on the features available in the platform. So I'll show you the dashboards and the meter templates available in the next couple of slides.
All the data profile related to that meter will be displayed in this faceplate. So you get monthly consumption data. You also get load profile for a day, week, month, or year, along with that time of use and kWh data. And you also see some comms activity, event count, etc. in this faceplate. We also have other widgets which we already explained in the home page, such as data availability percentage for a meter group or the communication summary for a meter group. You also have poll status data, which shows the percentage success or the failure rate of the polls that has gone into the meter group. Along with that, we see audit trail logs, which shows the recent actions of all users until the company performed for the system. We also have some GPS location related widgets, which shows the geographical location of all the field devices connected to a group. All the data profile.
So next one is a video on the meter template. So these are some small video snippets. So you can have the full-fledged video from the URL tiny.cc kalki.io MDP, that is meter data pack. Or you can go to YouTube and directly search kalki.io. You will get this video out there.
The user needs to first select the template for the relevant meters. We have several meter templates depending on the make and models of the meter available by default in the platform. Once the user selects the meter template, that meter type has to be added under this option here. Once the meter type.
So with this video, we'll complete the session for today. And so we'll directly move on to the question and answer sessions.
Yeah, thanks a lot, Nirmal, for the nice and insightful presentation. We've got a few questions from the attendees. The first question which has come from an attendee is, can you explain how the gap filling would work in the head-end system?
Yeah. So yeah, gap filling is an additional feature which we build on top of the protocol which is there. So what it does is that it's once the DLMS client reads the data from the meter and puts it in the time series database, there's a continuous service which scans the database periodically, and this service, what it does is identifies any gaps in the data which is read from the meter. Like for example, head-end was able to read data from particular time zone to particular time stamp 2 o'clock to 1 o'clock, but some few data from 1 to maybe 4 o'clock that data is not available. Then it will identify it as a gap and schedule those missed data for the next poll scheduler. So once the missed data has been scheduled, a DLMS client has got a feature called selective access. So selective access can be used to read the data for a particular entry, load profile entry, or it could be a historical profile entry, or it could be from with a from and to timestamp. So the LMS client will pick those gaps, timestamp, and read the data from the meter and fill it in the database. So that's how the high-level gap fill poll will work.
Okay. Yes. The next question is, before actual deployment of the head-end system in the field to read data from the meters, how do one test the scalability of the head-end system?
Scalability can be tested. So we have got a meter simulation tool which can be deployed on a server, and this tool can simulate up to 1 million meters, and you can configure the data profiles and the entries which needs to be made available in the simulator. And the simulator will serve the data from 1 million meters, and you can collect the data from these simulators. And again, you can have multiple instances of these simulators depending upon the scalability requirement. You can fine-tune the configuration of the simulators as required.
Okay. Another question which has come in is, can you share some more details on the disaster recovery feature in the head-end system?
So disaster recovery is a backend automated service which is configurable by the user. So depending upon the requirement on the disaster recovery, like it could be maybe per day all the data needs to be synchronized with the disaster recovery center. You can configure the synchronization mechanism from the main server to the disaster recovery center as per the sizing requirement or the regulatory or compliance requirement you have. And once it is configured, you can the data will be automatically be synchronized from the main server to the disaster recovery center. And there is a multiple calculator. You also has got multiple regions deployable for each users. So it could be on different time zones, like it could be on US, or it could be on Europe, or it could be on different area in globe. And you can configure a particular region as your disaster recovery center, and you can synchronize the data from one region to another region as per your requirement. So yeah, that's how the high-level disaster recovery will work.
Okay. There's another question not related to the cloud-based DLMS system, but yeah, but I think they will send out an email to us. Yeah, that's okay. You can send out an email to us at sales@kalkidec.com, and we will come back to you as soon as possible. Thanks, Nirmal again, and thank you especially to all the attendees for taking time out to attend this webinar. We will send out the video recording of this webinar shortly to all the attendees. Great. Thank you, and have a great day.
Thank you all. Have a great day. Bye-bye.